Hello everyone, my name is Ankit Nanwal and in previous lecture we have discussed about the resolution of the forces. Today we will be discussing about the numericals based on when the object is at inclined surface, so how we resolve the forces. So these are the nodes of the inclined plane nodes, in which this is the inclined surface, here this is angle theta, and suppose this body has been kept on this surface. So when this body will is at, there are two conditions possible. One is when the body is at rest on this surface and when it is moving. So when it will be moving, there is the case of friction there, but when it is at rest, so what will happen? So which all forces will be acting, that I have already discussed. One, the weight of this box or object that has been kept on the inclined surface will act vertically downward, that is weight. The weight is given by mass into gravity. Okay, and one is that force that is balancing this object on the surface, that is normal force, that is always perpendicular to the surface, that also has been discussed in previous lecture, that is denoted by n, normal force. Okay, now how you will resolve the forces? First of all, keep that in mind. For resolving the forces, when an object is at inclined surface, you have to assume the Cartesian system to be inclined. Okay, so this is x and this is y. Earlier we were for horizontal surface we are using this Cartesian system, that x is the x-axis is this one, y-axis is this one. For as object that is kept on an inclined surface, you have to assume that the Cartesian system is also inclined, and this is the y-axis and this is the x-axis. Okay, now for an inclined plane, for an inclined plane, weight always acts downwards, vertically downwards. Okay, that has already been discussed, that weight will always act in downward direction, vertically downward direction. Suppose I am having this pen, and when I will leave this pen, so it will fall downwards because it's having any mass, and the mass has been attracted by the gravitational force, so it will fall downward. That is weight of the object. Weight is given by force equal to weight force is given by mass into gravity. Okay, now the formula is mg. Object moves in the direction of the net force. That object which has been kept on an inclined surface will move in the direction of the net force. If net force is upwards, so object will move upwards. If net force is downwards, then it will move downwards. Objects on an angle have a force parallel to the surface and a force perpendicular to the surface. Okay, that means object which has been kept on the surface, one force is parallel to the surface and one force is perpendicular to the surface, and these forces, how we will calculate, that is resolution of forces. Normal force, that is denoted by Fn, or you can simply write down n. Normal force is always perpendicular to the surface, that has been discussed. That normal, suppose this is the object that has been kept on the surface, so normal force will always be perpendicular to the surface. Okay, this is the normal force. So now these are the some questions that has been, that you must keep in mind. Inclined plane questions. Okay, what direction does weight act? That means straight down or vertically downwards, you can write. What force acts down the plane? Which force will act down the plane? Down the plane means that is the parallel force. What force acts against the parallel force? Uh, if the object will start moving, suppose this is the inclined surface and this is the object in this surface. Okay, when this object will, when this parallel force, when this parallel force will act, if it is moving, the object is moving here, the opposite force acting will be frictional force. Okay, that is frictional force. So what force acts against the parallel force? That is friction force. In what direction does the perpendicular force act? Perpendicular force acts in perpendicular to the surface. As you can see in this diagram, that perpendicular force will act perpendicular to the surface. Okay. Now, what direction does the perpendicular force acts, that is perpendicular to the surface? Now last one is, what force acts against the perpendicular force? So which force will act against the perpendicular force? That is opposite to the perpendicular force, that is normal force. Okay, now the answer is normal force. Now there is there are more questions that you must remember, that which function is used to calculate the parallel forces, sine, cos or tan. So which force will come, that you will come to know after resolving the forces. So suppose this is the situation when this object is at an inclined surface. Suppose this is an angle theta. Now if this is angle theta, this will be 90 degree and this will be 90 minus theta, and this angle will be theta. Okay, now if this angle is theta, so this component will be, if this is weight component, then this component will be w cos theta and this will be w sin theta. So he is asking that which function is used to calculate the parallel force. So parallel force is having sine component, that is sine component. Which function is used to calculate normal force? Normal force opposite is cos component. This normal force is this one, and opposite to this is cos component. So which one will balance it? Cos component. So what determines, here it is given, what determines the size of the angle you work with? What will define the angle or determine the size of an angle you work with? Angle of the hill. It will define the angle of the hill. So angle will be dependent on the angle of the hill. This angle will depend that it is how much it is inclined. That will defined by angle of the hill, for which we are talking about. What is the hypotenuse of the vector triangle? Now this is very important. Now comes, what is the hypotenuse of a vector triangle? That is weight. How? That is very important question. That suppose this is a inclined surface in which this is an object that has been kept here. Now in this object there are forces, that weight is acting downwards. Okay. Now this is the parallel force and this is the what, the perpendicular force. Okay, now if this is the parallel force, so we need the vector triangle. So vector triangle is, this is the vector weight component, that is a vector as it is a force, and this is w cos theta, it is a vector, and this is w sin theta, it is a vector. So vector triangle will be formed when this one will come here, that is the w sin theta component. This is w sin theta, this is w cos theta, and this will form the vector triangle. And here this angle is 90 degrees. So hypotenuse of the vector triangle is given by weight component. So these are the basic questions you must remember in case of the object that has been kept on an inclined surface. So there are some activities that you must do at home. Number one, that this is the question. First of all, you write your name, and in this activity where you can label this diagram, 1 to 5 are the forces, 1 2 3 4 5. You need to write down the forces. Okay, which forces 1 2 3 and 4 5. Then 6 and 8 are angles, 6 and 8 are angles. Then you need to mention the angles also. So assuming the object is at rest, so this object is at rest. Okay, so which forces are represented by Fg sin theta? So whichever component you will get Fg sin theta, so which component it will be represented? It either it is parallel component or it is perpendicular component. You can write down that. And which force are represented by Fg cos theta? So this is another activity in which you will have to label the diagram 1 to 5 are forces and 6 to 8 are angles. That is very simple activity. I have already discussed the basics about these activities above. Now, this is the first question, that is, a 450 Newton trunk rests on a 30-degree inclined plane. So you need to find what is the force acting down the plane and what is the force acting perpendicular to the plane. Now, if this is the numerical, this angle is given that 30-degree incline, and a for 450 Newton trunk, this weight is force is 450 Newton. Trunk rests on a 30-degree inclined plane. So you need to find what force acting down the plane. So you need to find this, what force is acting down the plane and acting perpendicular to the plane. Down the plane means parallel force and perpendicular force is second one. So first part you need to find the parallel force, second part you need to find the perpendicular force. So how will you move further in this numerical? First of all, as it is given 450 Newton trunk, now you will first of all, as it is 450 Newton trunk, so its weight has been given, that is weight has been given, weight is equal to mass into gravity, and weight is given 450 Newton, that is weight. Okay, it is directly, it has been given. So you need to find the angle, then you have to resolve this component. As this is 30-degree, so now what you will do, this is 30 and this angle is 90-degree, and this will be 90 minus 30, that is 60-degree, and remaining angle will be 30-degree. So if this is 30-degree, this is W, so this component will be W cos 30, the component which is having an angle with it, that is cos component, and the other component will be W sin 30-degree. So now you know the value, you can simply first part says that what is the force acting down the plane. So this force is acting down the plane, so its value is given by W sin theta. Simply put the values, acting down the plane, that is 450 sin 30. Simply put the values, W value is 450 and sin 30 you can calculate it from calculator and you can get the value. Now B part say what is the force acting perpendicular to the surface. Simply you know the perpendicular case that you have calculated W cos 30, simply put the value of W and you can get the answer. Now the second numerical says that a 54.7 kg box is resting on a 5-degree inclined plane. Now the angle is 5-degree, and now mass of a box is given, that is 54.7 kg. So you need to find what is the normal force and what is the friction force holding that box. Now you need to calculate the frictional force that is holding the. So the first of all you need to make a diagram of it, that this is the box acting on an capped on an inclined surface, angle is 5-degree, its mass is given, that is 54.7 kg. So weight will be mg. So this is the weight one. Now this angle will be 5-degree. You can easily calculate, this is 5, this is 90, this will be 90 minus 5, that is 85-degree, and remaining will be 5-degree, that you know. Okay, now what will happen, simply resolve the component. The force that will be parallel to the surface will be W sin theta is 5-degree, and this component will be W sin 5-degree. Now you have the component first of all you want the value of that. What is the normal force? So normal force is perpendicular to the surface. This is the normal force. So in case of the this object is balanced by, so if this box is in equilibrium, for equilibrium summation of Fy equal to 0, that means if this force is upward, this is downward, that means N is the normal force that is been going upward. You can take upward force positive and downward force negative. As for equilibrium, this the summation of forces must be 0. So N is positive as it is going upward, minus W sine 5 degree must be equal to 0 for equilibrium, for maintaining the equilibrium, okay, in y direction. So N value will be W sine 5 degree. So you can simply put the value of W, you can take the G value as 9.81 also, or for simply easy calculation you can take 10 also. So this is the value of weight. Now you need to put the value of W and theta, calculate the answers. Friction force will be always opposite. Now when you will calculate this W sine theta, it will try to move this box downward. So frictional force will be acting opposite to the movement of this object. That is, if this value is coming out to be something, suppose it is coming 20 Newton, then friction will be in opposite direction of same magnitude that is holding that box, okay. That is, the value is 537 Newton of W. Now normal force will be W sine 5. W is 537 and cos 5. The value of normal force is 46.8 Newton, and frictional force will be opposite force that is in opposite direction of the parallel force, that is sine component 1, that will be W sine 5 degree, that is it. Now these are the basic numericals. This is how you can resolve the component. First of all, you need to remember that you need to take the Cartesian system as inclined for solving any numerical. You first, in horizontal case, when if you are doing resolution of the horizontal the object that are kept on horizontal surface, then you need to keep the Cartesian system simple like this. If x is in this direction and y is in this direction. For the object that has been kept on inclined surface, you can take the Cartesian system also inclined. Then you can easily solve this numerical. Okay. Now comes that these are little bit theory that you must know about the topic, the forces system. That is, when we push, pull, kick, lift, throw, flick, hit, pick, squeeze, press, inflate, open, close, and object. So these are all the application of forces. That means when you are pushing someone, you are pulling, trying to pull the ropes, for example, when you are kicking the ball, lifting any object, throw or flicking. Flicking means that you, in case of cricket, you are flicking the ball with your bat, with the help of your bat. Hit, pick, anything, that these are all the application of the forces. These actions are nothing but application of forces, okay. So in case of numerical, it may be given like this, that if this object has been pushed or pulled by a force, these are all the application of force. So what is the necessity of the force? The necessity of force is that, first of all, that to move a stationary object, example, the body is at rest, you want to move that object, so you need to apply force. So this is the necessity of force. First one, to change the direction of motion. Suppose any object is moving in this direction and you want to change the direction of the object and you want to move in this direction. Now how will you move? You will apply the force in this direction, so that the movement of this object can be obstructed by this force, and if this magnitude is more than the magnitude of force of this direction, then it will, that this direction of the movement will of this object will stop, and this will start moving in opposite direction. So for changing the direction of the motion of any object, you need to apply a force. To change the magnitude, if it is moving fast, if you want to slow the motion of this object, so you will apply the force so that the movement will reduce. The magnitude of velocity for speed, reducing the speed, these are all the necessity of the force. To say change the shape of an object, if you want to change the shape of any object, you need to apply the force. Okay, these are the necessity of force. Now what are the characteristics of force? Characteristics: forces are due to interaction of at least two objects. So when there will be a force is due to, uh, I have told you about the forces, types of force. There are contact forces and non-contact forces. So forces are due to the interaction. There should be an interaction between at least two objects. Then there is a force. Then there will be force. Okay, there must be two objects for the interaction of the force. Okay, it may change state of motion of an object. So that I have already told that it will change the state of motion. It may change shape, that has also been discussed. Force is applied on an object in the same direction and to one another. Now this is very important. Suppose if this object, here is one object and here is one object. Okay, if it is moving with the some force here, now the other force has been applied to this force in the same direction, so its magnitude, the resultant force, with the addition of these two forces. Okay, so I hope this is very important point. If they are moving in the same direction, then their magnitude will be added. The resultant force will be the magnitude of the two forces when the forces are in same direction. Okay, now when an object direction, when in opposite direction, when the forces are in opposite direction, then the resultant or net force is the difference between these opposing forces. So the direction of the object in case of opposite forces, suppose some force is there, some force is coming from there. Now which force will decide the movement of the object? That force which is having more magnitude will define the resultant direction. Okay, resultant direction will be defined by the force which is having more magnitude. Okay, if two same forces acting, the resultant zero. If two same forces acting and the resultant is zero, same magnitude, if two same magnitude forces is acting, suppose this is 5 Newton, this is 5 Newton, if they are coming together, then the resultant force will be zero, as both the magnitude has balanced themselves. Net resultant force will be zero. Now it is a vector quantity, so that has been discussed, that it is a vector quantity. Vector quantity, why? Because it is having magnitude as well as direction. If magnitude or the direction or both changes, then the effect of forces also changes. Suppose if you are saying this 5 Newton force has not able to pull the object, 5 Newton force is not able to move the object, this one. If I increase the force magnitude, now I have increased increase it from 5 Newton to 10 Newton, so its effect will also change. Now it may possible that it may change the movement of this object, or either it will move this object away from, as the magnitude of forces has increased. Direction, if you change the direction, now if you are saying that it is now you have apply the 5 Newton force from reversing the direction, now you have not applying the force from here, now you are applying the force in opposite direction, so it may be possible that its effect may change. So its effect will change if you change the magnitude and direction. So this is all about the force. Okay, I hope this point is clear. Thank you.